Hey there! In this video we're going to look at the mathematics behind selecting a suitable rainwater tank to harvest rainwater collected from your rooftop. So what we've got to do firstly is actually consider how much water we can collect, and that means looking at what kind of roof space we've got to collect our water from. So there's a number of considerations we've got to look at here, including not only the size of the roof space that we've got, but also the number of downpipes that we've got coming off of that roof space. If we have multiple downpipes, if we wanted to collect all the water, we'd actually have to have a tank connected to each of those downpipes. The situation I'm going to look at here is a lot more straightforward. We've got a carport, 11 metres long by 4.2 metres wide, which has a single downpipe at the end. So the first thing we do is look at the actual calculating the area of that roof space. So the area we can calculate just as 11 times 4.2, which gives us a value of 46.2 metres squared. To then work out how much water we can collect over the course of a year, we've got to look at the annual rainfall, or average annual rainfall. Now, so we're looking at the average annual rainfall in Adelaide, South Australia. So this is the figure that we're interested in. So this indicates that on average, Adelaide gets 546 millilitres of rain. So the volume of rainwater that we can collect is the area of the roof space multiplied by the amount of rain that falls annually. We need to convert that rainfall, so 546, divide that by 1,000, we need to convert that into metres, so that's 0.546. Putting that into our calculator, we get a value of 25.2 cubic metres, which, if we remember, 1 cubic metre is the same as or corresponds to 1 kilolitre when we're talking about fluids. So therefore, the amount of rainwater harvested per year is 25.2 kilolitres. So now we'll look at a couple of different kinds of tanks that we could possibly use to store our water. The first one we're going to look at is a rectangular tank. This is constrained by the fact that we've only got about 700 ml down the side of the carport to store the tanks. They could reach up to 2.4 metres quite comfortably because the roof space is quite high. And what I plan on looking at here is having 5 separate tanks which are each 2 metres long. So that will well and truly fit within that sort of 11 metres length of the carport. So what we'll do here is we'll begin by looking at the volume of each tank. So we've got our 0.7 metres, so that's converting the millimetres into metres, 2.4 metres high and 2 metres in length. So the volume is just those 3 dimensions multiplied by each other. So 2 times 2.4 times 0.7 gives us a value of 3.36 metres cubed, which corresponds to 3.36 kilolitres. Now we have 5 tanks, so the total volume that we could store is equal to 5 times 3.36, which is equal to 16.8 kilolitres. Now remember, we had total amount of rainfall was 25.2 kilolitres. We're able to collect 16.8 kilolitres of that. So if we look at percentage collected equals 16.8 divided by 25.2, times that by 100, put that into our calculator, and we get an answer of 66.7%. So we're actually able to collect 2/3 of the rainwater throughout the year, assuming that we don't actually use any of that rainwater throughout the year. So that's a reasonable amount. In practice, we certainly would be using some of that rainwater throughout the year, even though in Adelaide most of your rainwater falls in winter, and most of the rainwater used, particularly if you're wanting to water gardens and so forth, would happen during summer. So as our second example, look at a cylindrical tank. So remember, the volume of a cylinder is pi times the radius squared times by the height. Again, we'll stick with our constraint of 2.4 metres. So height equals 2.4 metres. Radius, given that the width of our driveway is about 4.2 metres, then the radius be approximately 4 divided by 2. So we're looking at a diameter of approximately 4 metres. So the volume from that, put put that into our equation. Pi times 2 squared times the height of 2.4 gives us a value of 30.2 meters cubed. So therefore, we'd be able to store 30.2 kiloliters, which is actually more than the annual rainfall. So we could actually reduce the size of that somewhat. Okay, so as a second scenario for our cylindrical tanks, we'll look at a case where we've actually got a fixed height still. We want to store all of the water that falls during the year, so that's 25.2 kiloliters, the height of 2.4 meters. So we want to work out what the radius of our cylindrical tank would be in this case. So again, we use our formula, but this time our value of r is unknown, so 25.2 equals pi times r squared times by the height of 2.4. If we rearrange that, we get r squared is equal to 25.2 divided by 2.4 times pi. Therefore r is equal to, we take the square root of both sides, 25.2 over 2.4 times pi. So we get an answer of r equals, so the answer in this case is equal to 1.8 meters approximately. So not massively different from our original tank, but probably gives us a little bit more room. But overall, the cylindrical tank would be a very impractical solution in this case. It would be taking up most of the end of our carport. It would make it very hard to get in and out of the side of the house, and it would look pretty ugly. So we've looked at a couple of custom sized rainwater tanks, a rectangular one and a cylindrical one, both of which meet our needs reasonably well, although the cylindrical one is quite impractical. Whilst it might be possible to actually get a custom made rainwater tank manufactured, it's going to be a lot more expensive than getting one, a standard size tank made. So to that end, I've selected one here. It's a 2,000 litre tank. It fits well with our constraints of being able to fit along the side of the driveway, only 5 metres wide. Each tank is about 2.4 metres long, so we're about to fit 4 of those tanks along the side of the carport. We've got 4 tanks, each 2,000 litres, so 4 times 2,000 gives us a total capacity of 8,000 litres, or 8 kilolitres. And if we look at that in terms of the percentage of the rainwater that is actually falling on the roof, so we've got 8 divided by 25.2 times that by 100 gives us a figure of roughly 32%. So about a third of the rainwater can be collected each year. Again, bearing in mind that we're going to be using the water along the way, that's probably a reasonable amount to be collecting.